What's up guys, my name is Ryan45678 and in this video I'm going to be doing a huge massive update on the Edger bike. The last video I made only had the engine and the throttle cable hooked up. So that's literally the last thing you guys have seen on this. Unless you follow me on Instagram, then you've seen my forks and the wheel, front wheel. I figured I would wait to make an update until I had pretty much all the parts I need besides the frame material. So what I've got, I actually drew it up in a program called FreeCAD. I'll link that in the description if you guys want to check that out. But this is basically what the Edger bike is going to look like. It's turning into more of a dirt bike and less of a mini bike. So those are the front wheels, if you couldn't tell. That's the forks. The frame is made of 1-inch pipe, which I will be getting at some point soon, once I learn how to weld well. This is the engine. There's a sort of jackshaft thing here, and there's a torque converter. These little things are chains. These are the shocks. Let's go to the other side. You can see the torque converter a little better. I'm going to have some different gear ratio setups here, going from the engine to the torque converter to another jackshaft, the jackshaft to the sprocket. Let's go over the parts really quick. So the main things, or at least the first things that I got, were the forks, the triple clamp, which came separate from the forks, and the front wheel, the axle, and the handlebars. So basically these are, I forget the exact length of the forks, but they're around 31 inches, I think, in height. The wheel is a 24-inch Northern Tool wheel, and I actually got it cheaper on eBay. The axle is 15 millimeters. I actually had to order a custom spacer from a place called Speedy Metals because the diameter of the wheel was different than the axle. And the axle is actually a little bit long, so I'm going to have to cut that off. And I'm going to have to machine the spacers down, or cut them or whatever, to make it even, because right now there's like one long one, there's one short one, and I want it to be even, so I'm going to have to cut those. I also ordered a custom piece from Speedy Metals to act as the steering stem neck, or whatever you call it. I'm going to have to mill that a little bit to fit the bearings because the sizes they had weren't exactly right, but that's okay. And to get that on, I'm going to have to take this section off. And I think that's it as far as the front end is concerned. So there's some more miscellaneous parts in here. I actually drew all this out to get an idea of what to do with the precision pieces, like the steering neck. I've got these are some master links. These are the rear shocks. I found a kickstand at Goodwill. It's for a bicycle, but it'll work. Here's one of the wheel spacers. Here is the neck thing I was talking about. I'm gonna have to take it down. It's actually better that way, because if the bearings fit exactly, they'd either be a press fit or they would fit and move around. So by having to take some of this off, it's gonna be better because it'll seat in there. So I'll have to do that. The next thing is in this box, which is the torque converter. It's a TAV2 Comet clone, and it's not put together. I'm gonna have to take. Well, let me explain some other things first. But I'm gonna have to drill out the jack shaft that this connects to on the front, because it needs a threaded hole. Next, we have the wheel, the back wheel. This goes to it's supposed to be for an SSR Coolster, which I think is like a 125cc Chinese pit bike or whatever. But I also found a sprocket. I have the sprocket somewhere. I bought a sprocket that's 41 tooth. Anything higher tooth-wise, and it gets really expensive. So that's the highest cheap sprocket I could find that fits this thing. And I found some bolts at an estate sale that happened to fit. I just got a bunch of bolts, and these actually will bolt it on. For all the bolts on this project, I'm probably going to use blue Loctite, because I don't want this thing falling apart because of some stupid bolt. But that's the sprocket and the wheel, the back wheel. The wheel was 14-inch, I believe. I'll double check that, but it's actually a lot bigger with the tire on it. I measured it, so yeah, we've basically covered this section of the bike. Let me explain, and I'll have another section of video showing you guys in the actual CAD program what I'm talking about. But essentially, this is a chain There's going to be a 16-tooth sprocket on the engine, a 10-tooth sprocket on the input shaft, which is a jackshaft assembly that I'm going to make for the torque converter. So that will, what I wanted to do with that was make it so that the engine doesn't have to spin as fast when it engages, because typically it's about 2200 RPMs before the torque converter will engage. And engines like this are only rated to like 3200, so that's basically 2/3 of the RPM range unusable. So what I figured out was a ratio that would get it to about 1500 RPMs, which is like the lowest. You can actually change the springs out and get it lower, but I figured that would get it low enough to where it can at least use half of its RPM still, and still idle and not engage the thing. And then the output to the torque converter is a 10-tooth that's provided with the torque converter. That's going to be going to a 27-tooth here, which is going to reduce the gear ratio substantially, and that's a jack shaft, and this chain is going to be going to the 41-tooth sprocket. So that's that. So let me show you what I've got for that. This is the jack shaft assembly I was talking about for the torque converter. So essentially, I can't mount the torque converter directly to the engine because it doesn't have mounting bolts for it. So I have to make something. The chain is going to go from the engine to here. And I don't know, I think I might put the sprocket here, I'm not sure. I might actually just put it here, we'll see. That's going to be an interesting challenge. And then somehow I'm going to have an assembly that mounts the torque converter that goes here. I'm going to have to drill and tap a hole for the torque converter bolt, and that will be that. So next, the next jack shaft, which is going to be this one essentially. It's not going to be quite this long. It was cheaper to buy this length. This is going to be the output from the torque converter. It goes to here. It's going to reduce the gear ratio quite a bit, and then these two pillow block bearings are going to be attached to the frame. This is going to be it's a smaller 10-tooth sprocket. It's going to be going to the rear sprocket, the 41-tooth. So that's going to reduce the gear ratio again substantially. So that's that. This box is the roller chain. It's 10 feet. I'm not going to take it out because it's underneath everything, and it's chain. If you want to see a chain, there's a chain. It's essentially that. As well, let's see, this is the 16-tooth sprocket. It's going to be on here. 10-tooth sprocket on the other side. And I brought an extra 10-tooth sprocket just in case the configuration with the 10 and the 16 to get the torque converter to spin faster sooner doesn't work or causes some issues. So that's this box. I did also find some bolts that fit these pillow block bearings at that estate sale. I mean, I didn't specifically look for that. I just bought a bunch of bolts, and some of them, by looking through them, happened to fit. So everything, all these jack shafts and things are 3/4 inch, by the way. Oh, yeah, at the same estate sale, I got this giant piece of steel. It's looks to be about 1/4 inch thick, and it's about let's see, 18 by 20 something inches probably. I'm going to use that either for the base for the engine. I'm not sure. I may just cut it and use it for, let me show you, pieces like this. I have two pieces that are going to potentially pinch the forks, I mean not the forks, the rear shocks, and then weld them to this piece, which is basically the swing arm, but it's just a 1-inch piece of pipe. So I'm not sure if that's what I want to do with that. I might, if I can find some cheap enough square tubing that'll serve the same purpose, then I might do that instead. Again, for the suspension, I didn't mention that yet. I'm going to be taking pillow block bearings, putting them on the frame, and just having a plain 3 to 3/4 inch rod going across to allow it to move, because otherwise, if you just weld that, the shocks are there, but it's welded here and it's welded here, it can't go anywhere, so it's got to move, and that's what that's for. One of the only parts I don't have yet is the rear axle, and that one is because I don't know, I mean, I drew this precisely in the CAD program, but I don't know for sure if that's how it's going to actually play out, because it could cause issues if I, like, say if I get the angle off here by a little bit, or if I get it too close or too far just by a tiny bit, and it could throw it off and I would have the wrong size axle. So I'm going to wait until I have the frame complete before I buy the axle. I'll just use, I don't know, I'll find something to stick in there temporarily just to check the fitment. Another thing I do not want to forget is to get some sort of grease gun, because these have grease fittings, and you do not want bearings to run without lubrication. They will die. Another important thing I don't have yet is brakes, because I'm not sure how to do that yet. I may get disc brakes if I can find some that'll fit that rear wheel, and try to make it a right foot brake. I'm not sure. Oh, another really important thing that I don't have is key material, which I should have ordered it when I bought this stuff from Surplus Center. It was like $2, but I thought, well, you could probably make it, but on second thought, it's kind of easier to just have some already and just cut it. So I'll buy some of that on eBay. And I don't have anything for the seat. I don't know what I'm gonna do yet. As far as the frame design goes, it should be structurally sound. I mentioned my plans for this to somebody that I know, and he was saying that he doesn't think a MIG welder is strong enough to handle structural things like that. I don't know, he could be right, but I've seen videos of people using the same welder, and they took 2 1/4-inch pieces of steel, 90-degree weld, tried to break it. It bent the metal before it even tried to break the weld. So I think it'll be fine as long as my welding is up to par, but we'll see. I'll do some testing and testing the strength of my welds, and if it's not, then I'll have to shell out some more money for a different welder. But I think it'll be okay. So as far as what I'm going to start doing next, I'm not entirely sure. I'll probably start doing the frame as soon as I learn how to weld. At some point I'll need to drill out this jack shaft, drill and tap it like I said. Probably start with this part, this being the easiest part to do, and the seat right here, and this. This is going to be interesting because I want this to be a precise angle for the rake and trail type thing to give it good geometry, but I'm not sure how I'm going to keep, that's another thing, I'm not sure how I'm going to keep all these pieces straight, because these have to, the base of the engine has to be 90 degrees, these have to be certain angles going up to, and I don't want it, say, I mean it's going to be about like either, I think it's going to be like this, if you can see that, it's going to be like this. And what I don't want is this, or I want it to be perfect. So I'm not sure how I'm going to do that exactly, but I'll figure out some way to do it. The main structural thing I might be worried about is here, which is right where it connects to the steering stem. If I need to, I could add an extra piece maybe here, or a little further down, I'm not sure. Or I could have another piece here, maybe coming to here, maybe some more cross here welded next to it, or like so I have so much, way more structure than I need. But yeah, that's going to be interesting. It's going to be a long process, I know, but it's going to be really fun, and the end product is hopefully going to be really awesome. So yeah, hopefully everything I've drawn here is going to work out, because that would suck if I drew something out and it didn't work. But I've allowed some tolerances, because the shaft on the engine, you can move the gear back and forth. It's actually got a pulley on it now, but I'm going to put a sprocket because I didn't want to deal with belts. It can move back and forth. The jack shaft is going to be pretty much fixed, because I should have bought a little bit longer one, but I didn't quite have, I don't know. I thought it'd be enough, and it probably will be, but we'll see. And this is going to be movable. Once I get this set, I'll do this, because this shaft is going to be able to move out. It's, say, you got the frame here. This shaft is going to have to stick out quite a bit, and it can change, because it's long enough. It can change the distance that it needs to stick out to be able to line up with this. And this, obviously, the sprocket on the inside of it, it's going to have about this much room to move at least. So that'll be easy to line up with the wheel, no problem, and it won't be in the way of the shocks. So yeah, I've rambled long enough. Hopefully this is interesting to you guys, but that's the massive, huge update on the Edger bike. It's all in pieces right now and doesn't even have a frame, but soon enough it will, and it will be looking like one of these babies. Not exactly, but you know what I mean. So yeah, I hope you guys enjoyed this video or found it useful / interesting. Don't forget to leave a like on the video if you enjoyed it. Subscribe if you want to see more projects, especially this one. This is going to be my main one probably for a while. But yeah, and if you want to support this channel, there are affiliate links in the description below. And yeah, I will see you guys later. Bye.